Hi, good morning, everybody. This is Bhaskar watching Bhaskar Time. So in the last videos, looking for interrupt masking, and exception priority, and all. Okay, today looking for one important block. What we are going to use in RM processor, that is NVIC. NVIC stand for Nested Vector Interrupt Controller. Sir, what is the usage of that one? How we are going to use, and what are the resistor internally we have, and how to control this one? These all things we'll discuss today in this video. Okay, so first looking for what is NVIC, Nested Vector Interrupt Controller. It is an integrated part of Cortex M3 processor. Yes, it is an integrated part of the Cortex M processor. You can see in the block diagram. So Cortex M processor. So internally should be having processor core along with that you have a NVIC block. It is integrated part of your Cortex M3 processor. Okay, its control registers are accessible as memory mapped devices. It has some control registers. So it has some control registers. These are act as an some of the memory mapped devices. Okay, NBIC also contains control register for the MPU, the system timers, and debugging controllers. We already seen that one. Once we're looking for internal structure of previous way, NVAC also it consists of some of the control registers, and it is also memory protection unit, and also it consists of system clock timers and debugging controllers. Okay, you can see that. So you have some NVAC system timer. It is also connected. Some debugging components it will be connected. Non-musculature peripherals, everything should be is connected here. Okay, the NVC supports 1 to 240 external input interrupts IRQs. So we can see that it will support 1 to 240 IRQs. It will be supported. It is coming from the input output ports, or maybe it is from the peripherals. It will support. Okay. NVC also has non-maskable interrupt input. Yes, we can see in the block diagram. So NVC also it consists of one NMI, is nothing but non-maskable interrupt. Okay, so this is NVIC also has non-maskable interrupt input, and NVIC can be accessed as memory location of 0xe0002E100. So it is E00, so 3E followed by 302E followed by 100. It is a memory address what we are going to access. We can see that it is an architecture, Cortex of the processor, NVIC block we have along with distance of peripherals, input output devices what we are connected, and this in order to control my NVIC is nothing but we have an interrupt. I need to control that one. In order to control that one, we have some configuration registers. And what are the configuration register what we have? Not only that, I already told that. See here it is NVIC what we have in this case. We can see that NVI is having some memory addresses. Internal should have MPU also it is having. So address have one address we have. So similarly, it should be controlling all the parts. These are all things will come under your system control space. Okay, now you see that what are the control resistors what we have. So we'll discuss that one. The config, so not control resistor, it is configuration resistors. Okay, see there are a number of resistors in the NVIC for interrupt controller, exception type 16 up to 255. I already know that when see the exception 0 to 50. So we see that after 15, 16 to remaining cases 255, what we are going to use it for interrupt. We seen in the last video. So here also, these are what we are going to use in order to control 16 to 255. We are looking for some of the resistors in NVIC. These resistors are located in the system control space. That's what I'm telling. So all the resistors, these are special resistors, are present in your SCS space. So in order to control all my exceptions, ranges from 16 to 255. Okay. So what are the things? What are the resistors we have? First one, it is enable and clear enable resistors. So you have a, in order to do enable and clear, you have a one enable resistor and set pending and clear pending resistor. Okay. Another one it is a priority level resistor. Another one it is active status resistor. We'll see one by one what is the function of that. Okay. First one it is enable and clear enable resistor. See, if you want to you have an enable resistor. If how to enable that one, how to clear that one. So you have not to start my NVC blocks, I need to enable enable, right? We see the procedure when come to an NVA, sorry, exception procedure and exception sequence. We already told that. So I need to enable my NVIC. So how to do that one? So suppose if I want to clear all the data as my NVIC, how to do that one? So in this today video, we're looking for how to do enable and how to clear the particular bits. Okay, the interrupt enable register is programmed through two addresses. One is to set enable bit write to NVIC ISER interrupt set enable register. ISER nothing but interrupt set enable register of n bit register address. To clear means you have a that one also you have NVIC ICER. ISR is nothing but for enable. So ICER is nothing but now to clear this one what we are going to use. Then how to do this one? Just see. ISER and ICER register have 32-bit wide, each bit represented as one interrupt input. So remember, so it is each one it is 32-bit wide, each bit represent one interrupt. So if each bit of that one, it is helpful for to do the interrupt operations. Okay. See here it is I given an address, it is starting address. I told that 0x of E000, E1002, E00, E11C. It is interrupt set enable ISER register and it is ranges from 8 bit 0 to 7. What we are going to tell. It's very simple. In this case, what I'm telling, try to telling. So if I make the particular bit it is equal to 1, then it is act as an enable. So suppose if I want to clear means just ICR, I need to make it, suppose if it is 1 means it is a particular, so interrupts it will be clear. So what is the range is looking for 180 to 190, and if I want to clear just NVIC ICR 0 to 7 bit, write to 1 to clear enable, write to 1 set enable. Okay, this is my ICER and ICCR. It's very simple. If I want to enable, if you want to set enable register and how to do this one, then how to clear enable register. You just particular bit make it is a 1 means that value become it is clear as well as set. Okay. Next, you're looking for interrupt set pending register, sir, and clear pending. So why we are going to use? See, first register what we are going to use just how many interrupts is there, and just we are checking that one, and also in order to activate my NVIC. Now here it is how many interrupts are pending. So I want to check it out, right? How many pending is there? Suppose if any interrupt it come to an existence, when highest priority interrupt come to an existence, then what I need to do? I need to stop the process and execute. Suppose having the lowest interrupt come to an existence, what we'll do? We need to keep that very pending state, right? So I need to stop after execution of highest priority interrupt. After that, this pending interrupt will be executed. So in order to do how many interrupts are pending, if you want to remove the pending list, if you want to clear the pending clear, and if you want to set that one. So how to do this one? For that cases, we're looking for some of the register. If an interrupt takes place but cannot be executed immediately, for instance, if another highest priority interrupt handler is running, it will be pended. Yes, the interrupt pending status can be accessed through the interrupt set pending register. So an interrupt clear pending register. Okay. So if I'm going to make the particular bit ISPR, remember ISPR nothing but interrupt set pending register. PR stand for pending register. Okay. So if you want to set, you need to make it is equal to 1. If you want to clear just ICPR, you need to make it as a 1 means the pending register will be clear. Okay. Next, looking for another register priority level. So as usually when come to an interrupt, it's having some highest priority interrupt as well as lowest priority interrupt. Suppose if you want to set a priority, highest priority, so I need to change one, right? Yeah, each register can be further divided into preempted priority levels and sub priority levels. We already seen in our exception cases in the previous video. Okay, preempted priority level or group priority level and sub priority level based on the priority group setting. So if NVIC IP stand for priority level interrupt priority. Okay. So IP looking for interrupt priority level 8-bit wide for each interrupt. Just we are going to setting the priority 0 to 239. I can set the priority of that one. Okay. Next, it is active status. So how many interrupts are active status is there? If you want to check, we are looking for this. Each external interrupt has an active state is whether in a processor start the interrupt handler. So when the processor start the interrupt handler, so we need to check that whether it is interrupts are active state or we are going to use this register. So okay, the bit is set to 1 and clear when the interrupt return is executed. Suppose If it is not executed, it is continuously executing means we will make it as a particular bit, it is equal to 1. So active state bit read only. So easily we can read, we can't write that one. Suppose if maybe it is IABR, so it's not an interrupt active bit resistor. IABR nothing but interrupt active bit resistor what we are going to use. If it is equal to 1 means easily we can read that. Okay, next it is one of the special resistor what we are going to use. One, it is a software trigger interrupt resistor. Okay, it is STIR. Okay, beside of using NVIC ISPR resistor, you can also software trigger interrupt resistor also is there. Okay, so we already discussed the last cases what is the usage of trigger and which mode EPR can be operated and unprivileged, non-privileged, everything we discussed. Okay, to trigger the interrupt using the software. So how to do this one? Software trigger interrupt resistor we already having. It is called STIR. Software STIR stand for software trigger interrupt resistor. Write on interrupt number to set its pending status. So we are going to write the interrupt number to set in pending status. Okay, and this core function, how to write this one? Just we are going to use NVIC ISPR in NVIC underscore set pending IRQ timer 0 IRQ. And this is a way of writing of my C function of my interrupt. Okay, software trigger interrupt resistor. Okay, this is our NVIC. If they're asking, need to know that. So what is my NVIC? Why we are going to use and where it is present? Actually, it is always into your Cortex core processor core. After that, what we are discussed, it's very simple. Enable resistors, pending resistor, priority level resistor, and active status resistor. So what is the meaning of ISR, ISER, and so it is nothing but so ISER nothing but interrupt set enable resistor and how we are going to use. And after that, we're looking for pending resistors and active resistors. What we are going to use very simple. Please study this one.